Welcome back. Today we are diving into a topic that's, absolutely critical for building high-performing AI applications, but it's one that often gets overlooked. We are talking about chunking, the real secret sauce that can make or break your LLM app.
So picture this. You've built a retrieval augmented generation app, a RAG app. You're using a top-of-the-line large language model, but the answers you're getting are inconsistent, irrelevant, or just, wrong. It's a super common and frustrating problem. And listen, more often than not, the issue isn't the model, it's how you're feeding it information. Okay, so what is chunking, really? At its core, it's just the process of breaking down these huge pieces of text into smaller, more manageable segments. The best way to think about it is like a library, right? You wouldn't hand someone an entire encyclopedia to find one little fact. No, you'd point them to the right volume, the right chapter, and the right page. Chunking does the exact same thing for your AI.
Now, why do we bother with all this? Well, there are two huge reasons. First, it's just a technical thing we have to deal with. Embedding models can only handle so much information at once. That's the token limit or context window. If your text is too big, it just gets cut off. Simple as that. But the second reason, and this is the really important one for quality, is search relevance. A good chunk needs to contain a complete, self-contained idea. That makes it so much more likely to be found when a user asks a relevant question.
Now, I know what you might be thinking, but hey, what about these new models with these massive million-token context windows? It's a great question, but they aren't a silver bullet. They often suffer from something called the lost-in-the-middle problem. Basically, if the perfect answer is buried deep inside a giant wall of text, the model can actually just miss it. Smart chunking completely solves this by serving up focused, relevant little bites of information. This leads to a really simple but incredibly powerful rule of thumb. Just ask yourself this. Does this chunk of text make sense on its own to a person? If the answer is yes, you're on the right track. The whole goal here is to create these semantically complete little packages of knowledge.
All right, so we get the why. Now let's get practical. Let's open up the developer's toolkit. We're going to start with the most common and honestly the most effective methods that you can get up and running with right away.
Most developers go on this kind of natural journey with chunking. It usually starts with the simplest approach, which is fixed-size chunking. Then, as your needs get a little more complex, you move to more nuanced, content-aware methods, and you often land on a really nice, balanced approach like recursive splitting. So let's break these down.
So, this brings us to a really core trade-off. On one hand, you have fixed-size chunking. It's fast, it's easy, you just pick a number, say 512 tokens, and you just chop up the text. The big risk, though, you can slice the sentence right in half and completely destroy its meaning. The alternative is content-aware splitting, which is smarter. It respects natural breaks like sentences or paragraphs. It creates much better chunks. But, yeah, it's a bit more complex to set up.
And that brings us to a fantastic middle ground, recursive splitting. It's so smart. What it does is it tries to split along the most meaningful boundaries first, like paragraphs. If a paragraph is still too big, okay, it then tries to split by sentences, and then words, and so on. This really gives you the best of both worlds. You get these semantically coherent chunks that still respect your size limits.
Okay, so that covers the standard toolkit. But what happens when your data isn't just a big block of plain text? For complex, structured documents, you're going to need some more advanced techniques. This is where it gets really cool, because you can let the document's own structure do the work for you. So for example, if you're working with a PDF, you can split it by its headers and sections. For HTML from a web page, you can use tags like paragraphs or titles. For Markdown, you use the headings. It's like you're leveraging the built-in logic of the document itself to create these perfectly contextualized chunks. Now we get to the real cutting edge. One method is called semantic chunking, and this is fascinating. It uses embeddings, which are just numerical representations of meaning, to group sentences that are talking about the same thing. It literally finds the exact points where the topic shifts. Then there's a totally different approach called contextual chunking. This actually uses an LLM to write a tiny summary of the whole document and attaches it to each chunk, giving even the smallest pieces a ton of high-level context. Okay, we've seen a lot of methods here, from the super simple to the really complex. So, how on earth do you choose the right one for your project? Well, it really just comes down to asking yourself 4 key strategic questions.
First, and this is the most important one, what is your data? The way you'd chunk long-form articles is completely different from how you'd handle, say, short chat messages or structured computer code. The nature of your source material is always your starting point.
Second,
which embedding model are you using? Because different models have different token limits, right? And they might even tokenize text in their own unique ways. You have to align your chunking strategy with the specific capabilities and behaviors of the model you've chosen.
Third, you have got to think about your end user. Are they going to be typing in short, simple keywords, or are they going to be asking long, complex conversational questions? Your chunks need to be sized and structured to match the kind of query you actually expect to get.
And finally, what's the ultimate goal here? Is the chunk just being shown as a search result? Is it being used to put together an answer for a Q&A system? Or is it feeding crucial data to a complex AI agent that needs to make a decision? Each one of these applications has totally different requirements for context.
Okay, so you've answered the questions. You've picked a strategy. But don't stop there. Now comes arguably the most important part of this whole process, iteratively testing and refining your approach until it's just right.
So what does that actually look like? Here's a super simple workflow. The key is, don't just guess. Pick a few different chunk sizes, say 128, 256, and 512 tokens. Process your data for each of those sizes, and then run a set of real-world test queries against them. See which size gives you the best results, and then iterate from there. It's science.
And here's one last powerful technique to have in your back pocket: chunk expansion. The idea is brilliant and simple. You search using small, focused chunks for maximum speed, but once you find the best match, you also grab the chunks directly before and after it. This adds way more context for the LLM to work with. You really get the best of both worlds, a fast initial search and a rich, contextual final answer.
So, does all this effort actually make a difference? Oh yeah, absolutely. Just look at this case study from the company Delphi. By implementing a smart chunking strategy for their conversational agents, they were able to reduce the time spent just on data retrieval to less than 30% of their total response time. I mean, that is a massive real-world performance gain. Which brings us to our final thought-provoking question. We're in this arms race for bigger and more powerful models. But what if the secret to truly intelligent AI isn't just about building a bigger brain, but about getting much, much better at preparing the information we feed it? It's